Okay, this is my Unit 4 Mastery Project FRQ. I'm doing number 1. So Part A1 says, which aspects of Student 1's reasoning is any are correct? Explain your answer. And Student 1 says, rocket Y will have a smaller maximum vertical displacement than rocket X, although it is launched upward with the same speed as rocket X and has more kinetic energy than rocket X. Because rocket Y will have a smaller maximum vertical displacement than rocket X, I predict that it will take less time for rocket Y to reach the ground compared with rocket X. So, let's see, in rocket X, so rocket Y is heavier than rocket X. So Student 1 is correct in that rocket Y will have a larger, rocket Y's kinetic energy will be larger than rocket X's. And this is because if the two rockets have the same mass and they both have the same initial velocity, then that means that the kinetic energy of the heavier rocket will be more. You can think of it that it takes more energy to move the heavier mass with the same amount of speed than the smaller mass. Okay. So A2. Which aspects of Student 1's reasoning are incorrect? So Student 1 is incorrect that the rocket Y will have a smaller vertical displacement. So even though rocket Y weighs more, it still had the same initial velocity. So rocket Y displacement is equal to rocket X displacement. And so I think what might have confused Student 1 in this question is that that the rocket Y will have a smaller vertical displacement. I think they thought that because they had a larger mass, and so they thought the larger mass would I guess go up less, would have a lower Y value for the displacement. So this isn't the case because, again, they needed to have more energy put into rocket Y in order for it to have the same initial velocity. So that's why rocket Y will have the same displacement as rocket X, even though it is heavier. Okay, part 3. Which aspect of Student 2's reasoning is any are correct? Let's see. And Student 2 says rocket Y will have the same maximum vertical displacement as rocket X. Both rockets have the same kinetic energy. Says by the same vertical displacement. Okay. Yeah, Student 2 is correct that the rocket Y will have the same amount of vertical displacement, as I said before, because rocket Y had more energy put into it, so it had the same amount of the same initial velocity, even though it was heavier. So that's why it'll have the same maximum vertical displacement as rocket X. Let's see. It'll also take the same amount of time for the two rockets to reach the ground. This is because even though rocket Y is heavier, mass doesn't mean that an object will fall faster. Okay, part 4. Incorrect. So yeah, student 2 is incorrect that the rockets will have the same kinetic energy, because the equation for kinetic energy first is what, half mv squared. Yeah, so mass is in it. So since the mass of rocket Y is greater, rocket Y has greater mass, and so it'll have greater kinetic energy. And this really makes sense because you need to put more energy into moving something heavier than if you're going to move something lighter the same distance or the same speed. Okay. Part B, use quantitative reasoning. Maximum heights. Derive expressions for the maximum heights achieved by rocket X and rocket Y. Express your answer in terms of initial velocity, mass of rocket X, mass of rocket Y, gravity, and fundamental constants. So we can use the kinematic equation. Vf squared is equal to v0 squared plus 2ax displacement, and we're solving for the maximum height. So if you just isolate delta x, then you get, so you won't have a final velocity because you're going to a maximum height. It'll be 0, and then so you can do, let's see, negative initial velocity squared divided by 2ax, which will be gravity in this situation. That'll be equal to delta x more delta y, since you're going up. But yeah, and that'll be your equation. Okay, part C, use reasoning, including equations as needed, to derive expressions for the time it takes rocket X and rocket Y to reach the ground after reaching their respective maximum heights. So you can also use the equation, kinematic equation, x equals starting position plus initial velocity plus half x t squared, and then they'll both be starting at the same place, so you don't need x sub 0, and they won't have any velocity to start with, so you can cancel the initial velocity and time. So now you're left with, and the maximum heights are h sub x and h sub y, so h sub x in place of x is equal to the initial velocity plus half, and gravity is acceleration in this example. So it's that times 2 hx plus 3l over gravity. Isolating t for both rockets will get you this, and then let's see, and yeah, and those two are the answers. Part D, explain how any correct aspects of each student's reasoning identified in Part A are expressed by your mathematical relationships in Part B. So Part B, we said displacement is equal to negative initial velocity squared over 2g. And this makes sense because the displacement will be no mass is included in the displacement because they're going to have the same initial velocity. So mass does not affect displacement if initial velocity is the same. And you can see this because there's no mass in the equation to solve for delta x or displacement. And then part 2, that was part 1. To explain how any correct aspects of each student's reasoning identified in part A is expressed by your mathematical relationship in part C. So the time it takes for the objects to fall, as you can see in the two equations, the time, or the equations to solve for time will be the same. And this is true in our analysis in part A, that the time it takes for rocket Y to reach the ground is the same for the time it takes for rocket X to reach the ground. So in part 2, we can say time it takes for rockets to reach the ground are the same. And this is because the formulas are the same. And because everything else is the same, obviously, because the only thing that's different between them is the mass. And mass, again, is not included in any of these equations. It's just initial velocity is the same, gravity is always going to be the same, and we already determined earlier that the displacement will be the same. So that's why it'll take the same amount of time to reach the ground.